Okay, let's start now. Hello, everyone, and very warm welcome to our final webinar this year, Christmas edition, the final forest restoration talk. You know already that for those who haven't joined us, I will still explain. The forest restoration talks is a series, a webinar series that is jointly organized by the SUPERB project and the IUFRO task force, transforming forest landscapes for future climates and human well-being. And in this webinar series, we investigate forest restoration questions from various perspectives, scientific perspectives, also sometimes perspectives of practitioners. And we do this with an alternating focus on the global and the European level. And in the series, we bring together researchers, practitioners, NGOs, policymakers, and other interested stakeholders to explore practical forest restoration approaches, experiences, and also challenges. And I'm really happy that today we have Christina Dollinger as a speaker. She is a researcher at Technical University Munich, and her research interests are in ecosystem modeling, ecosystem dynamics, forest management, and she's also working on protected areas, and we'll learn more about that later. Her topic for today is the restoration of mountain forests in the Berchtesgaden National Park, both with a short and a long-term perspective on success in the face of climate change. And before I hand over to Christina, there's some housekeeping rules that I would like to share with you. This webinar is being recorded, and we will make the recording available afterwards to watch it on YouTube and also via the IUFRO website, the EFI YouTube and the IUFRO website. And if you have questions to the panelists, please use the dedicated Q&A box. We will also, to make it more interactive, we will promote you, once you've asked your questions in the Q&A box, we will promote you to speak live. In case you don't want to be promoted, just refuse the promotion, and then we will read the question. But it's nicer and more interactive if you actually ask the question live. And in case you want to tweet about the webinar, please make sure to tag us using either IUFRO or SUPERB project, or in the best case scenario, both. And I think that was it for the housekeeping. Now I would like to hand over to my colleague Christina, and I'm really curious to learn about your research, about the recent paper that you published, and what your perspectives on restoration of mountain forests in Berchtesgaden National Park are. The floor is yours.
Thank you, Gesche, so much for that nice introduction. Yeah, I'm super excited to be presenting in this cool context with so many participants. I just started sharing my screen, and we just practiced this before, so this should hopefully be working fine. And I see the nod from Gesche. Okay, that's great. Okay, so I don't really need to introduce myself anymore. And the topic also, so I think we can just get started. So let's take a look at mountain forests and the challenges they're facing at the moment and will continue to face in the future. So here you see one of these mountain forests. You see a disturbed site, to be specific. And mountain forests are facing major changes due to two main drivers, which are both shown in this picture. So here you can see the lack of snow, which is due to climate warming, which is already happening and expected to accelerate in the future. And in the foreground, I don't know if you've noticed it, but here we see a big disturbance, which in this case was caused by bark beetles. And disturbances are already and are expected to further increase in the future in severity, size, and frequency. The forest seen here was especially vulnerable to these changes because it's a forest that was where Norway spruce so Picea abies was promoted in very dense, homogeneous stands for the goal of timber production and forest management. And this picture was taken in the Berchtesgaden National Park just recently, which is also the focused area of my research, or the paper that was recently published in the Journal of Applied Ecology. So the Berchtesgaden National Park, or BGNP, which it will be called on the following slides, is located in the southeastern corner of Germany. As you can see here, it borders Austria. And this is what the landscape looks like. It's about 20,000 hectares big, and like any national park, divided into a core zone, which makes up about 75% of the landscape, and then a management zone. And in here, I've shaded the areas where we have a lot of spruce in green. So you can see in some parts, especially in the management zone, which is this non-shaded area, we see about 90% of spruce in some regions even, which is still this human impact that is visible from the past centuries of forest management. And we would naturally not expect these high proportions of spruce, especially in the management area, which are located in the lower elevations of the national park. And this is what these homogeneous spruce stands look like. So they pose a challenge for the national park. The national park was founded about 45 years ago, and it has a few responsibilities, especially to preserve the near-natural communities, but also to bring about a natural development in these or towards these more natural communities. And the administration of the national park translated these responsibilities into restoration efforts, with the goal being stated in the Nationalparkplan. So this was formulated about 35 years ago. And it states that they want to promote natural succession towards more semi-natural forest stands, which are to develop naturally on their own in the future. And from this, they define some restoration strategies. But first, I want to quickly define what they meant by, or what they mean by semi-natural forest stands. So these are mixed mountain forests with beech and fir. Spruce is still found in these forests, but not as in high proportion as it is found there now. And this, of course, is not a typical fir that I'm showing here on these slides. This is supposed to kind of get us into the Christmas spirit, because some species of the genus fir are used as Christmas trees. And I've also attached a little challenge to this picture of the Christmas tree, and I want to ask you to count the Christmas trees you can find on this slide. So this already counts, and the following slides, to make it a bit fun. But away from the Christmas tree challenge to the challenge for the Berchtesgaden National Park. So now in the present, the National Park Administration came to us with the following questions. First of all, they wanted to know whether the restoration efforts, which have been taking place for 35 years now, are showing an effect, so whether they are working. And also what the future of these restoration interventions is, considering that climate change is completely changing the whole biosphere and forest dynamics. So this is what we looked at in this study. So now a bit on the study setup. It was a two-tiered design where we used field studies to answer the question about the present effect of the management, and then also a simulation study where we looked at possible futures of the National Park Berchtesgaden. So to start with the field studies, this was field work that was done by 2 master students in the National Park, Freya Löffler and Sven Döring. And they specifically looked at the regeneration layer, so trees with a height above 20 centimeters. And they looked at different types of sites. So they looked at sites where planting had taken place and where plantings hadn't taken place, and also at sites where wind disturbance had taken place a decade ago, and also undisturbed sites. For the simulation study, I used the forest simulation model Island, which is able to simulate single trees across whole landscapes. So there's different ecological processes being modeled at different spatial and hierarchical scales, starting at the single tree scale and then going up to the landscape level where, for example, disturbances and seed dispersal are then modeled. There's a bunch of different modules that can be integrated into Island. For this study, I used the 2 disturbance modules for wind and bark beetles, as they're the main disturbance agent in the national park. Bark beetle is, in this case, Ips typographus, which especially targets spruce trees. And to simulate the restoration efforts, I used the 8 management engine, which is, for example, able to dynamically react to disturbances, which is what we needed for this study. So I, in total, simulated 3 different restoration strategies. The 2 active ones are based on historic and current restoration efforts that have been going on in the management zone of the Berchtesgaden National Park for the past 35 years. And the restoration strategies basically focus on replanting the currently underrepresented tree species, fir and beech, in different types of gaps. And who wants to look at the word fir? We can also look at a very nice breath of a Christmas tree. Okay, so these are the 2 active restoration strategies. The proactive restoration one is the most intense one, where replantings not only take place in disturbance gaps, so naturally occurring gaps, but also in gap cuts, which are gaps of about 0.2 hectares that are cut into especially or heavily spruce-dominated stands. The reactive restoration strategy, on the other hand, only reacts dynamically to naturally occurring disturbance gaps. And the passive restoration strategy is a no-active management strategy. So this is basically what is taking place now already in the core zone of the national park. So here, no plantings took place in either of the gap types. What does the implementation look like? Well, in the field, it looks like someone planting some young trees. In the model, it looked like this. So here you can see a very, very small part of the simulated landscape. Every single dot is a tree, and in dark green, you can see the spruce trees. So this was a heavily spruce-dominated stand where in the middle of it, we cut a gap of 50 by 40 meters and replanted it with little beech trees in light green and fir trees in dark blue. So then we tried, or we had to figure out, in order to answer our question, what the actual target state of the restoration goal is, because as you remember, in the management plan, it only said semi-natural forest stands, which is pretty vague and makes it very hard to gauge whether a restoration strategy is successful or not. So what we did is we tried to quantify this goal, and we did this by running PNV simulations, which are potential natural vegetation simulations under historic climate and disturbance. And potential natural vegetation basically means the vegetation you would expect depending on the specific site characteristics, but again, under the assumption of stable climate or historic climate and disturbances. And then finally, the simulation design looked like this. So I simulated from 2021 to the end of the century, so 80 simulation years under 4 different climate scenarios: historic climate, which is climate from the years 1980 to 2009, and then 3 different climate change scenarios. So the RCP scenarios 2.6, which is pretty moderate, very optimistic climate change scenario, up to the very extreme climate change scenario of RCP 8.5, where we see a warming of about 6 degrees Celsius by the end of the century. And I replicated each of these scenarios for 10 times. So let's get into the results. I want to start with the field studies, and to show you what is going on in the regeneration layer, I use this very simple bar chart. So here on the y-axis, you see the trees per hectare. So these are, again, the trees present in the regeneration layer. And on the x-axis, you have the species of interest, so to say, because we want to increase the proportion of fir and beech and decrease the proportion of spruce. And the first, or the left column, gives us the results for the undisturbed stands. So in this case, this would be a closed spruce-dominated stand. And the right columns gives us sites where a wind disturbance had taken place about 13 years ago. And you can see that in sites with no planting, which is the first row, the red bars, we have very sparse regeneration. In the undisturbed stands, beech dominates, which makes sense because it's a shade-tolerant species. In the disturbed stands, however, spruce dominates. what does this look like, or what does the regeneration layer look like in sites with plantings? Pretty different. So this is now shown in blue. We see here that we have overall higher stem densities and a lot more fir and beech, but still spruce remains dominant, which is a pattern we're going to continue seeing also in the simulation studies. But I'm getting ahead of myself. So the first key finding is that the plantings that have been going on are actually helping fir and beech, and we can see this success in the field in the national park. So let's get into the future of the national park and look at how composition and structure are going to change if we continue this restoration management for the next 80 years. But first under historic climate. So this is not showing any climate change results yet. So first I'm going to show composition. Here you can see the proportion of the different species as shown in these colors. So we have in dark blue fir, in light blue beech, in green we have spruce, and then we have some other common species of the national park in these shades of brown. And let's look at the left bar first. So this is the present state in the national park. As we saw already with the map before, we have a very high percentage of spruce, about 75%. On the right bar, however, we see what we would expect in the national park. So this is now the result of these potential natural vegetation runs. Here we see that we would actually expect beech to be dominant, to make up about 50% of the tree species, while spruce is the second most dominant. And we see that we would expect about 13% fir compared to 1% fir now. So a pretty big difference between the present state and the target state, or the state what we would try to reach with the restoration management. So what do you think happened in the 80-year period? I'm going to reveal it now. So this is what composition looked like after 80 years of simulated restoration management. The shown here for the 3 different management strategies. So we do see a shift in species composition. We see that fir and beech increase under all management strategies, so they at least double in their proportion. We see that spruce decreases in turn, and that the signal is strongest under proactive restoration, which is the most intensive restoration strategy where more trees are planted. But we also see that we're very, very far away from the target state, even after 80 years of simulated restoration management. So this gives us the next key finding. We see an increased compositional diversity by 2100, but we do not reach the target state. We're pretty far away from it still. So what does this now look like for structure? I've used the coefficient of variation of the tree diameter as an indicator for structural diversity. The current value is about 0.4, and the value we would expect under potential natural vegetation is about 0.7. And here we see that after 80 years of simulated restoration management, the structural diversity really increased by a lot. We even surpassed the target state under the proactive restoration. So the next key finding is we see an increased structural diversity by 2100, and we even reach the target state within this century. So now let's look at the effect of climate change. Shown here is another bar chart, and on the y-axis we have the 4 different climate scenarios, going from the historic climate scenario in blue up to the very extreme climate change scenario, RCP 8.5. And on the x-axis, you see the proportion of fir and beech, as they're the species that we want to increase the proportion of. And we see that climate change actually increases the proportion of these species up to a proportion of about 0 or about 30% under the most extreme climate change scenario. We are still, however, really far away from the target state, which is this green line at about 60%. So spruce decreases under climate change, but still remains dominant even with a warming of 6 degrees Celsius. And for structure, we saw that there's a slight increase over the climate change gradient, but overall it's not that climate sensitive. In any ways, we're already pretty much reached the goal even under historic climate. So the next finding is that climate change actually accelerates composition recovery. And then you ask yourselves, well, why is that? So why is climate change increasing the proportion of fern beach? And for that, we need to take a look at the disturbances and how they changed under climate change. So showing you here now is the area disturbed by different disturbance agents. In the first row we see the wind disturbances, and they very slightly increase over the climate change gradient. So going from the left column up to the right column, and in colors are the different management strategies. So wind disturbances are not really reacting very sensitively to the climate change, so they can't really be the driver of the compositional recovery we're seeing. We think, or an explanation for the patterns we're seeing might be found in the increase of bark beetle disturbances. So they very strongly react to climate change, and we see an increase of up to 4 times an area disturbed under the most extreme climate change scenario, which leads us to the conclusion that climate-mediated disturbance increase are an important driver of forest dynamics and composition recovery. So these are the questions that we asked ourselves before, and now these are our answers. So we were able to show that the restoration efforts of the last decades are working. They are showing results. And in the future, we see that active restoration, it leads to a faster increase of composition and structural diversity. Passive restoration is slower, but is still showing the same trajectory. So there also we see an increase in structural diversity, a decrease in spruce, an increase in fir and beech, and climate change is actually accelerating these patterns. So the question still remains, however. Now let's try to answer it. Was the restoration goal reached, or can it be reached? Just to remind you what the goal was. I think this question is not so easily answered, like anything in ecology. So it depends. If we focus on the part where it says that they want to create semi-natural forest stands, we would have to say, well, it kind of failed because the species composition of the target state was not reached. We still had way too much spruce and way too little beech and fir. However, is a restoration target based on the potential natural vegetation still a sensible goal? Because as I said, PNV assumes stable and historic climate conditions and also disturbance regimes, which is not an assumption that anyone with eyes would and a brain would probably make in the face of climate change and the ongoing changes to the biosphere. So as a restoration goal, I don't think PNV is very suitable. So let's look at the other part of the goal that they formulated, where it says that they want forests that develop naturally on their own in the future. And here I could say, this did work out, or we did see signs of this working out in the future, because compositional and structural diversity increased. This was even accelerated by climate change. And this happened under passive restoration, so where no plantings at all took place, which makes it a viable option for an ecosystem like Berchtesgaden. And with that, I want to thank you for listening to me. I also want to thank my supervisor, Professor Rupert Seidel, my mentor, Dr. Werner Rammer, and Freya Löffler, one of the master students who helped me with the data analysis of field data. And now finally, it's your turn, because I want to know, but I think I won't be able to know how many Christmas trees you counted. So I think this will just have to be an exercise that you do for yourself. And I'm going to reveal it in a few seconds. Okay, so there were 11 Christmas trees in the presentation in total. You can see them here circled in red on the different slides. I'm really excited to hear how many you were able to find.
I have counted 11.
Oh, that's great. Okay.
Yes.
Congratulations.
Yes. particularly because we had our Christmas party yesterday, and I didn't expect myself to be so sharp, so I'm really proud. There were smaller and bigger Christmas trees. That's also something that I that I recognized.
Yes.
It was a really nice exercise. Yeah, I hope and it also helps people to stay focused. So
Okay.
very good tip for also for everyone in the audience. I don't see any questions in the Q&A yet. Please make sure to ask your questions there, or to also to raise your hands or to provide a comment. If there is no question from the audience yet, I have a question which is related to your projections, and you mentioned that under all kind of different scenarios there would still be a high percentage of beach, and I was wondering, so beach would also be one of the kind of remaining dominant species despite the kind of climate change related impacts. And I was wondering, because I know that beach is also suffering from climate change and disturbances, and mainly also from drought. So I was wondering, like from a like, if like we take a practitioner point of view, would that be desirable to have this high percentage of beach?
That's a very good question, because it kind of gets at the overarching theme of what is a sensible goal for restoration management, considering that there's so much uncertainty about the future competitive success of these tree species, which have been able to grow under the current conditions very well, but are already now showing signs of suffering from drought, for example. So I think for the National Park Berchtesgaden, we are still invested in beach. I think it is a species that will be able to very well exist there even in the future, because it's a relatively wet environment where even though the temperature increases by a lot, we will still be within the climatic niche of beach. For other parts of Germany, I would not want to answer these questions for a practitioner, or I could not be able to answer these questions with the study that I did. But I think the overall question of what is a sensible goal, or what factors should we look at when we decide which tree species to promote in the future, is a very exciting and very difficult one to answer.
Yes, and we will certainly also focus on this topic in this webinar series, because it's also very important for the different superb demonstration areas all over Europe, where in some demonstration areas we focus more on the restoration / climate change adaptation. But in other areas we have faced severe disturbances, for instance, from bark beetle or wind throw damage. And there it's really the question what to promote in the future, what to plant, what to kind of lead to, what we can leave to natural regeneration, etc. Particularly when it was a spruce monoculture before, then you really need to consider this carefully. We have a question from the audience, and I can see that Digi is already promoted to be a panelist. Digi, do you want to ask your question live?
Hello.
Hi.
Hi, thank you, Christina, for a very interesting presentation. I am Degi from Mongolia. So we have done some similar studies in Mongolia years ago, but it was much slower. So I was curious if you have used any specific model for projection of the different restoration scenarios, or how did you simulate the different scenarios?
Thank you for that question. It's so cool to have people also from other countries listening to my talk. Super cool. Thank you for joining. I used the simulation model Island, which was developed about 12 years ago by Professor Seidel and Dr. Rammer. And it's a very data-hungry model, I would say, because obviously to set up a whole landscape, you need a lot of information about the abiotic environment, so for example, soil, but then also, of course, the vegetation, its current state. But once you've set it up, it's a very, very powerful tool for simulating the impacts of different drivers of forest dynamics. So, for example, the different climate change scenarios I was able to simulate, but you can also simulate different management strategies, as we also did in this study. And this is what we use. So Island has already also been implemented in a bunch of other places in the world. We haven't gone to Mongolia yet, but I think we're always interested to set up some new landscapes and get them running.
Yes, Diggy,
Great,
take this as an invitation to collaborate with Christina.
Yeah, that would be great. Yeah.
And we have another question from Argentina, actually. Monica doesn't have a mic, but she has a question, and I'm happy to read it out. She wants to know if there's a policy in place to foster restoration in national parks. And also the question is related to the ownership of the land. Is it public or private ownership?
So unfortunately, I'm not an expert and I don't have the information on the restoration strategy for other national parks. I know that for mountain forests, Berchtesgaden National Park is kind of a beacon project, so I haven't heard of anything similar or done on this scale, and especially already now for nearly 4 decades. So I think in that sense, it's a very unique project. And the land is public. So I think on private land it would be a different, you'd probably have different goals. You have way more shareholders. Of course, also in the national park, it's not a decision that is taken lightly, because obviously also the public wants to use the park, and the park has to fulfill a bunch of different functions. So not only so restoration management has to work inside of the limitations of a national park, which is used by many different types of people for many different types of reasons.
I have a related question which links to communications, because that's obviously my field of expertise. And it is like, how do you collaborate with the national park? And are they actually planning to use your simulation results for their activities?
Yeah, so our chair, the chair of ecosystem dynamics and forest management and mountain landscapes, is very closely linked to the national park. So my professor is actually also the head of research in the national park, which is I think a super powerful cooperation, which was spearheaded by the Bavarian Forest National Park and Jörg Müller. So this is a super cool environment and way to do very high-level research in a national park for us. And the national park is planning on using the results from this study for their further management planning. They have already used results from our research, not my research, but from other people's research in the past. For example, when they switched from this proactive restoration strategy that I was talking about to the reactive restoration strategy. So this was kind of a dream project for me, because it was a question that came from practitioners, had a very concrete kind of answer that we were able to a concrete question that we were able to answer with the study, which is now going to have hopefully a positive impact on the further management of the national park.
Thanks. Yeah, it's just really a great chance, I think, to have this like really applied research, which not every researcher has. So that's I agree that this is great. And I have another question related to that, and then we also have quite some questions in the Q&A. When you say beacon project, are you also planning to investigate other mountain forests, are you do you have collaboration with researchers in Europe or also outside of Europe who investigate restoration in mountain forests?
No, there's no such cooperation at the moment. We do have other research projects at Acera, however, where we cooperate. For example, a colleague of mine, Michael Maruszek, looked at disturbance regimes of different protected areas all across the Alps. So thankfully, there's this great network which we could harness for further research projects.
Okay, so also here, in case you're interested in collaborating, please approach Christina. We have another question related to disturbance regimes, and it comes from Daniel Agos, and he is asking about fire dynamics, which is maybe not the kind of most straightforward thing to think about, but considering climate change, and also the fact that mountain forests can be affected by fire. Yeah, I think it makes sense. So do you have an answer to that?
Yeah, so fire is not a big or barely a driver or a disturbance in Berchtesgaden National Park. There have been fires even just a few years ago, but this one was actually put out, even though a danger to the surrounding neighboring forests and towns, and also to the visitors of the national park. But we do expect it to become a more important driver all across Europe. A colleague of mine, Mark Rünig, did a simulation study where they saw that big and severe fires are expected to increase in Europe, and I guess that also means they might increase in the National Park Berchtesgaden. But again, because it's a relatively small area, which is especially to the northern edge of the national park, surrounded by towns and neighboring forests, I don't think big fires will occur there, because they will be put out before they can grow to significant size.
Yes, thank you for that answer. I will share the link to Mark's study in the chat. I read it as well. I can very much recommend it. Maybe it's interesting for you, Daniel. There's another question from an anonymous listener. And the question is, do you think we should rethink the concept of the core zone without management in the national park? And then the second part of the question is it better to restore with an active approach everywhere in the national park Berchtesgaden?
I do really like the concept of a core area where no interventions take place, even though in a national park it still means that, for example, core zone. But I do think it's important to have these kind of wilderness areas, of course, even though wilderness is a term that is probably not very applicable in a continent as densely populated as Europe. But if we can get a bit of wilderness, if we could, for example, get some big predators back in the national park, that would be definitely exciting for restoring natural ecosystem processes, which is also a big goal of a national park. And then I think the second question is kind of answered by my first answer as well, where I think I don't see the need now for restoring anything in the core zone. So that would be the one part of the answer, and the other part would be that I think the resources needed for doing restoration on such a big area. So already on the 25% of the management zone, it's a very big effort to do these restoration measures, and it wouldn't be feasible on the scale of the whole national park area.
Yeah, exactly. It's also one thing is the idea, and then the other thing is the actual capacities to implement these measures. So that's also something that needs, like when it comes to the practical terms, needs to be taken into account. We have another question from Natalie. Yeah, it worked with the promotion. Please, you can ask it yourself, Natalie.
I can't hear anything.
No, I can't hear anything either. So then I will do it myself. Natalie wants to know if there is a specific place that you collect the seeds from to make sure that you are promoting a variety of genetics, or the second part of the question. Yeah, it's related to the seeds collected from the local area.
Unfortunately, I don't know anything about the provenance of the seeds that were used to grow saplings, which were then planted. So it was mostly saplings that were planted. But I do know that part of the future strategy of the national park when it comes to these restoration measures is to get away from the planting saplings, but to focus more on trees which can act as seed sources for further restoration. So as I showed, we still have too little beech and too little fir in the national park, but now the idea is to find big seed-producing beech trees and fir trees and see whether they can be protected or promoted in any kind of way so that they will hopefully provide the very obviously very locally adapted sources for seeds which can then grow into future beeches and firs.
Thanks, Christina. Natalie, do you have a further comment to that or a response to that?
Yeah, I was just curious about it due to the fact that with climate change, you know, a lot of the genetics that are being planted, you know, there's the bark beetle that are affecting the trees and causing these extreme disturbances. If there was a group of trees that you guys collected from for the resistance to these beetles or to any of the diseases that they carry with them too. But if you're not sure, that's totally understandable since it's not part of your study. So.
No, but thank you so much for the question. I think I really want to find out now where they got the seeds from beech and fir from, because also for beech, there's so many different provenances, right? You could also get it from maybe some drier regions, which would then maybe make the beech that is growing up now or generating now in the national park less sensitive to future climate change. So it's a really interesting question. I would assume that it's probably very local, currently adapted provenances that they used as for the seeds.
Yeah, which is understandable.
It's the less controversial option.
Yeah, I fully understand that. I worked in a national park where we were doing alpine restoration on white bark, and we had to do certain collections and had to find ones that were specifically resistant to the bark beetle and the rust. So,
wow, super interesting. Yeah, I'll definitely put it on my list of questions to ask the park managers.
Yeah.
Thanks, Natalie.
Thank you.
We have a question from Michael, but we have a question that is a little bit, so you'll be the next one, but I want to ask the question in the chat that is a little bit related to Natalie's question, actually. And then it's your turn, Michael, afterwards. So the question from the chat is from Justino Messalira, and it is related to the introduction of different origins of main species, in particular with regards to beech and fir when it comes to the adaptation to climate change. So using the same species but with different origins, like maybe from like more from the south.
Yes, this is a super interesting avenue for further research, I would say.
Okay, then you will take it into consideration. This is also highly relevant for Superb, because I know in some demonstration areas, for instance, we do it. The case of Milan, I know that they introduced tree species more from the south of Italy, but the kind of the same species, but with different origin, to anticipating certain changes in climate, that those species would be more adapted to than the species that are growing there at the moment. So so this is something we should definitely investigate in the future. Michael, now it's your turn. Michael Kleine from IUFRO.
Yeah, thank you very much. Yeah, thank you, Christina, for this very interesting presentation. I just wanted to get a little bit at these biotic disturbance factors you used, because you are, of course, modeling 80 years or quite a long period of time. And when you look at your spruce proportion in the stands, which do not change so much as actually anticipated in these restoration targets, there are examples in the Alps where actually, for example, bark beetle attack actually wiped out 14,000 hectares in the eastern part of Tyrol, and disturbances, very erratic, huge disturbances in one year and then very little in the next year and so on. So first of all, how did you do this for your assumption? Because I think that in the worst cases can even happen that spruce proportion goes drastically down, even in other parts of the Alps, including the northern limestone mountains. So just to explain a little bit how you have modeled this would be, I think, very interesting.
Yes, very interesting questions. Crazy numbers from Tyrol. So the bark beetle module is climate sensitive. So there's spikes in years where it's, for example, especially dry and hot, which then enables the bark beetle, the simulated bark beetle in our model, to produce more generations per year, which of course then increases the beetle load basically and makes it more likely for them to disturb huge areas of spruce. So this link between climate and bark beetle activity is captured in the model. And it's also spatially explicit simulated, so the beetles move around the landscape and the model remembers where the beetle was in the year before. I think we won't get numbers as extreme as in Tyrol, mainly due to the fact that it's a pretty topographically complex landscape. So the beetle would have to be extremely synchronized across years in order to be able to kill huge continuous area of spruce. And I think that's why we still see a lot of spruce remaining even under extreme climate change in the simulations.
May I just add one more issue to the discussion? Because I think connected with that, of course, our ability to predict the future, of course, is limited. I mean, no doubt, but it shows trends and pathways where things can go that we can act today. But that leads me to the issue of restoration targets in management zones. I mean, it's very clear in the core zone, whatever stable vegetation you create doesn't matter so much what species composition, because it should be vegetation cover, it should be the soil protection, should be all these things, and the vegetation should survive. But in the management zone, I think the problem is that in addition to the restoration target, there is an economic component, because this is being managed for some wood products, other products. So you combine here, always under a certain management scenario, also a restoration target. And that becomes, of course, very critical. And some of the colleagues mentioned this already in the lower lands. And I guess the Berchtesgaden is all above 600-meter elevation. But the real problems in Europe are below 600 meters, where then beach gets much more attacked by drought and all these things. So interesting would be, what is the national park's target in the management zone, not only in terms of restoration, but also in terms of the economic return or value they expect from that, because then the species composition becomes very critical.
Yeah, so maybe the word management zone is kind of misleading. It's also sometimes called a buffer zone. So here there's no economic value to be gained from the management zone. So the only other considerations for the national park when doing this restoration interventions were, of course, protection from natural hazards, for example, where continuous forest cover is useful, and maybe also some aesthetic reasons, because it's obviously being used as it has to be a nice scenery for
recreation
visitors.
And right. Okay.
But apart from that, no economic issues have to be taken into consideration, which of course puts the national park in a very privileged situation. And also what you mentioned with the relatively high elevation and high precipitation, this is not something that you find in many other areas where we're facing the same problems.
Well, thank you very much. Thanks.
You're welcome.
Thank you very much for the question, Michael. And I don't see any further question in the chat that I would like to share. Maybe one final question from me. Considering like one of the original ideas for organizing this webinar, to giving it a Christmas touch. A more general question, and I also know that you probably won't be able to answer it kind of for entire Europe, but considering the different species that we can use for Christmas trees, including fir and spruce, what is your prognosis, your projection for Christmas trees in Germany in the future? Will we still be able to use Christmas trees, or should we kind of also adapt our consumer behavior and maybe go for something else, considering the fact that some tree species will really are already suffering and some might suffer in the future?
This is a question I can't really answer in my capacity as a scientist. Of course, I do have some personal preferences. I'm always for consumers rethinking their choices, because even though a single choice might not seem like a big deal, there are a bunch of us, so our collective choices then make a big difference. And for example, me personally, we don't have a Christmas tree anymore. We decorate one of our big room plants, and it's the best thing ever, and it feels really good not to have to throw away a dead tree every winter. So that's my answer. I can't really give any projections about European or Germany scale. I know that a colleague of mine is working on a paper where he talks about the competitiveness of different tree species in the future, but I guess we'll have to wait until that one comes out.
Okay, we can follow up then in due time. Thank you very much, Christina, for the engaging talk. I learned a lot, and most of the participants actually stayed. So this also links to your excellent presentation. Gabby, I would like you to share the kind of final slide, which says thank you to all of you for your active participation. Okay, so before closing the webinar, I want to announce that the plan for next year is actually that we will, in the first webinar, which will most likely happen in January, maybe we will postpone to February because a lot of people will still be on leave in January, we'll focus on a recap of the ongoing or recently finished COP and the kind of related outputs for restoration, for forest restoration worldwide, and an evaluation of the discussions during the COP in Dubai. And for getting to know more about this, we recommend you to follow us on social media or to go to our superb website, where we will update you on a regular basis. And for the time being, thanks again to Christina. I've shared her recent paper in the chat. And I wish you all a very nice holiday season, and looking forward to engaging again next year. Bye, everyone.
Bye. Thank you for the opportunity.
It was a pleasure. Bye.